Hello and welcome to QED Stata 4. In the first part of this class, we will look at some simplified small data sets in different contexts just to practice applying the t-test and a modified form of the t-test called the paired t-test. In the second part, we'll work with a much bigger and much more complicated set of real-world data from the World Values Survey. And before we start doing the analysis, we'll learn the very useful skill of merging together data from different sources, which is something that many students and researchers like to do when they start researching topics they're interested in. And then we'll apply some t-tests to that data to finish with. So let's get started with this first set of data. And for the first set of data, the first set of exercises, I put all the data together into a single Excel file, so you can import each one in turn to do the little bits of analysis. So we're starting with this data on Burkina Faso. So let's assume that you've read all that. We're going to test these hypotheses. We want to know whether the mean price paid by farmers is 12,000 francs against the alternative is that it's more than 12,000 francs. So we're seeing if the price has gone up, or if we're seeing if the price on the private market is higher than the subsidised price, which is supposed to be 12,000. So let's look at the data from the sample. So let's find stata. Seems we've more than a minute into this video, you haven't seen stata yet, so it might be an idea to find that. We're going to use the Excel import, which is all stuff we cover for spreadsheets. Find the spreadsheet you want. Q-test, there we go, that one. You see there's lots of different ones here, so it's the Burkina one we want first. Import the first rows. See, at the moment the variable names are inside the data, which is no good, so you do that, and then that picks out the variable names. So always, virtually always do that, otherwise you get a mess. That should be it, hopefully. See if anything happens. That seems pretty good. Then we'll get some descriptive statistics using SU. I'm assuming that you kind of have followed some of these commands from previously, so I won't give you every single last detail all the time, because in actual fact, what's the variable? Price variable, okay. If you just do SU, and then the price is called price, that'll give you the basics. Well, let's see what that gives you that. But if you want the slightly fuller version, as shown in the document, the instructions, you have to go for the detail option, which gives you that. So that gives you slightly fuller information about the maximum, the minimum, the quartiles and deciles and so on, as well as variance skews. A whole bunch of stuff on these 176 observations, so you can get that fine. Okay, so the question is, what does this mean? Does it look from this data as though they are paying more than that 12,000 francs? Well, yeah, the mean is 12,219 francs. So does this mean that farmers are paying more than 12,000 per sack on the private market? Well, of course, this is 176 farmers, this data, but there are more than 176 farmers in Burkina Faso. There are thousands or millions of farmers in Burkina Faso. So the question is, are those millions of farmers paying more than 12,000 on the private market based on this? So this, okay, the sample is above 12,000. Is that grounds to say they're paying more in the market? Or could there be some reason why the sample is not giving us good information about population, which is why we need to do a test. So we're going to test on these two hypotheses, and the hypotheses talk about all farmers, so the whole population, not just this 176. So let's run the test and see if we can get something along the lines where it's supposed to be. So t-test that the price is equal to 12,000. And in stata, like some other programs, when you're testing if something is equal, you write 2 equal marks. If you just put 1 equal sign, that's still making something equal. So price is equal to bars 1200. Yeah, don't put a comma in the 12,000. That was pretty. That's okay. So there's the output. Let's see. So I think on here I'll put the fully labelled up version so you can see which bits are which. So I'm not going to read through all of that, but please ask me questions if you're not sure about that rather than me reading through it all. But when you're doing the test, the key point is you bear in mind, what's my null hypothesis? It is that mean price is 12,000. And the other thing you need to bear in mind when looking at this is what kind of data will make me reject this. My alternative is that in the private market it's higher than that. So if my sample data is coming out with a lower price than 12,000, then there's nothing to see here. Okay, so the private market is not, there's no evidence that the private market is more expensive than the subsidised price. So I'm only going to reject it if I get higher. So what I want to know is, I have got higher, 219, so 219, 220 above the subsidised price. So what's the chance of getting that much higher if, in fact, in the whole population it's 12,000? What's the chance I can select a random sample of 176 with a mean 219 higher? That's why we look at this alternative here, the alternative being higher. So this is the relevant value. So your work is, do the t-test, easy, just type a formula in, but then the understanding work is, which of these three p-values do we need? The answer in this case is the one at the end, because our alternative is that it's higher. So the chance of getting data as high as we've got above that, if the null hypothesis is true, is 0.008. So it's less than 1 in 100, less than 1%. So if I stick with this belief, the null hypothesis is true, null hypothesis is true, I just have to accept that something happened which has got a less than a 1 in 100 chance of happening. And that should mean I'm thinking of perhaps this thing I think is true, null hypothesis, that we've thrown some doubt on that. So in formal terms, we would reject that. And because it's less than 1%, we can reject it at the 1% significance level, or with 99% confidence. So as it says here, to conclude, according to the test, it does provide strong evidence that the mean price by all farmers on the private market is more than 12,000. So that sample is giving us a significant result because it tells us something about the population. Okay, so hopefully that's clear, but the last question here is saying that, remember, this is not certainty. You'll never get certainty. Imagine that this is wrong, and that despite the results of the test, in actual fact, H0 is true. On the private market, price is 12,000, maybe even less than that, so there isn't actually a higher price in private market. How could that be? Well, there's different parts of it. The most basic level could be that the numbers we have in that sample are just wrong. These are not the numbers that those farmers paid for it. And they maybe just forgot, or they're exaggerating or underestimating. So for some reason we got the wrong information from those farmers. They told us the wrong thing. And there's two ways of that. It could just be they slightly forgot, which is not too bad, because then some might have high, some too low. Or it could be that they're worried that we're investigating, so they're going to play it down, or they think that we're going to take action to push the price down, so they're going to increase their estimates. They could be systematically biasing what they say in one way or another. So it could be that there's measurement error, either random or non-random measurement, or systematic measurement error. The other one could be that, okay, so those numbers from the sample are correct for the sample, but for some reason that sample is not representative. We picked people in the sample who pay more than the general farmers pay. And again, there's two possible reasons for that. Could be the way that we carried out the way that we selected the sample was doomed from the start, because we were selecting people in areas that are not representative, or we're just selecting people that came forward themselves, and they're probably ones that are annoyed they paid too much. So it could be there's a problem with the way we did the sample. Okay, and again, the test can't help us with that. So the test can't help us if we have the wrong numbers for any reason from the sample, and it can't help us if the way we got the sample was foolish, so it was biased. However, even if we got the right numbers and we did everything correctly in terms of setting up the random sample, so every farmer in Burkina Faso, in principle, had an equal chance of being one of those 176 people, even then, it can go wrong. Because even if every farmer has an equal chance of being in the sample, it could be that just by bad luck, we just happened to get, just randomly, some farmers who paid more than the actual average for all farmers. And that, there's nothing we can do to eliminate that, apart from maybe taking a bigger sample. But otherwise, we've done everything correct, just chance has misled us. That's what the test can help us do. It says, okay, if you do everything right, you guys, and if it's true that the null hypothesis is correct, what's the chance then you can randomly, just through bad luck, end up with a sample as far away from what the real mean should be as we did? And that's what the 0.008 is, that less than 1%. So as long as we've done everything correctly, the chance that randomness has given us error is 0.08%. So in that case, we say, as long as if we're sure about the measurements and the way we did the sampling, then we can be 99% confident of rejecting that null hypothesis. So the evidence here is pretty good. Okay, so don't panic that we're nearly at 10 minutes and it's still the first test. I'm not going to go through all this for everyone. I'll just show you how to do the stuff in stata for most of it. But it's the same kind of logic about the hypotheses and the interpretation of the result will apply. Okay, so let's move on to the next example in the next video, and thank you for watching.